Hey Precalculus. So the other day we were graphing polynomial functions and their graphs. To be clear, a polynomial is any function with positive integer exponents, so they have to be whole numbers. Okay. And you have to have real number coefficients. So the numbers in front of your x's and any sort of numbers after there have to be real. This guy is definitely an example of a polynomial, and to begin with, if I'm going to do anything with it, I want to factor it. So I see that there are 4 terms, which tells me I'm going to factor by grouping. So I'm going to group the first 2, group the last 2. I can factor out an x squared, which leaves me with an x minus 2. And I should be able to factor out a 4. Oh, and I think, did I write anything down wrong on this problem? I did. This should actually be a minus 4 up here. Sorry, I wrote the problem down wrong initially. So then I'm going to factor out a negative 4, and I'm going to get x minus 2 here. I knew that something was wrong because I wasn't going to get the same thing in both sets of parentheses, and in order to factor by grouping, you have to. So now I'm going to factor it again. I can take out a common factor of x minus 2, and I'm left with x squared minus 4 from these 2 pieces. And then x squared minus 4 I can factor again. So I have x minus 2 times x minus 2 times x plus 2, because x squared minus 4 is a difference of squares. Now if I want to get my zeros, I set each factor equal to 0. So I'm going to say x minus 2 equals 0, x minus 2 equals 0, and x plus 2 equals 0, and I'm going to solve. So here I get x equals 2, x equals 2, and x equals negative 2. Notice that this 0 is repeated, and if a 0 is repeated, we say that 2 has a multiplicity, which means it occurs multiple times, of 2. If it was repeated 3 times, we would say 2 has a multiplicity of 3. If it was repeated 6 times, it has a multiplicity of 6. So it's how many times it's multiplied, or how many times it's repeated. Okay? So this is a new vocabulary word that you may or may not have seen before. Now when I go to graph this, I graph my zeros. So I'm going to have a 0 at 2. It's technically a repeated 0, so there's another one there. You just can't really see it. And I have a 0 at negative 2. I'm going to go and label those. And now it comes time for me to graph and to find some other points here and to see what the end behavior looks like. To do that, I am going to use the aid of my graphing calculator. So I'm going to plug into my y equals x cubed minus 2x squared. Oops, sorry, I gotta put that in. So x to the third, I've got to make sure I get out of my exponent, minus 2x squared minus 4x plus 8. I go into my xy table, and I'm going to look and see about how big these are. So at negative 1, I'm at 9. At 0, I'm at 8. To be able to see these points, negative 10 to 10 should work for me. And then after that, I'm going to start getting really, really big. And in this direction, I'm getting really, really small into my negatives. So for my window, I'm just going to do a regular window to start with and see if I can see the tops of my curves and the bottom of my curves. And it looks like I can. Okay. So let's plot some of these points. Go back to my table. Let's see, how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8. It looks like I'm going to run out of space if I wanted to plot to go negative 1, 9. And so I'm going to make these go by 2s. You don't have to have your x's and your y's change by the same amount each time. You can change them by different amounts. So there we go. So I'm going to graph negative 2, 0, that's good. Negative 1, up 9. 0, 8. Let's see, 1, 3. 2, 0. If I go over to 3, I'm going up to 5. And then 4 is 24. That's going to be off my screen. Let's see if I pick up any others here that I can graph. Negative 3 is down 25, so I'm not going to be able to see that either. Next, I want to find my mins and my maxes. Now, you can tell that this guy is a minimum at 2, 0, but I want to find that maximum up there. It might be at negative 1, but it might be a little bit off of that. So I'm going to hit second calc, max. Left bound, let's see, I'll do -3. Right bound, I'll do 0 and hit enter. And I get a maximum of -0.66 and 9.48. So I'm going to go back a little more than half, up almost to 10, and I get that max in there. And I'm going to write the max in on my paper. So -0.66 repeating, 9.48. Okay. And then I'm going to sketch in my curve as nice as I can. Now, technically, this isn't actually the biggest that the graph gets. It's what we call a local maximum. Or your textbook also uses the word extrema for those little tops of the peaks and bottoms of the valleys. So 2, 0 is what we would call a local minimum, also an extrema, you know, to the extreme. If I were to talk about end behavior here, I would want to know what's happening to f of x as my x is going to infinity. In this case, since the arrow is going up, my end behavior is that f of x or y is also going to infinity. And on this side, as x is going to negative infinity, so as my x's are getting smaller and smaller and smaller, my y's are also going down. So my y value would be going to negative infinity, or I could say f of x. End behavior is not to be confused with increasing and decreasing intervals, so you have to be careful there. If I was to write out where my function is increasing, I would need to think about the slope of the curve, and I would need to think about what would happen if a little guy was running along my curve. So in that case, my little guy always runs from left to right, and if I was a little person running on this curve, I would be running up between negative infinity and my maximums using the x coordinate, so -0.66, repeating, using a bracket there. And then I would also be running uphill from 2, using my x coordinate, to infinity. That means I would be running downhill if I were a little guy, so I would be decreasing between these 2 points, so between -0.66 and 2. All right, that's it for your 3.1 notes. I will see you guys tomorrow. Thanks.